Okay, welcome to day 8, the antiderivative. We've been working with taking derivatives for a long time now. Most of Unit 4, all of Unit 5. Today we're going to work on undoing the derivative, or something we call the antiderivative. So if lowercase f is a function, capital F is the antiderivative of that function. So if you recall in the last exam, I gave you something that was like this. Maybe not exactly that. I gave you f prime of x was equal to 2x to the fifth plus 1/2 x to the fourth minus 5x cubed minus 7. Not exactly, but something like that. And we were doing the antiderivative. I said you had to find the original function. And most of you put down something like f of x was equal to 1/3 x to the sixth plus 1/10 x to the fifth minus 5/4 x to the fourth minus 7x. Okay, so what you did here, you did the antiderivative. You started off with something and you undid it. It's the undo. Ironically, I don't think any of you guys did it, but you could have added any number here at the end. Here you could have added 5, you could have added 8, you could have done -6, you could have done anything you wanted at the end here. And that's what we're going to do. We're going to work on taking the antiderivative. So capital F prime is the original function f, and the capital F will have an added c at the end. It will be based on some initial condition, but in general we just do plus c. We will determine the c later. Okay, so in math we like to use symbols, and one of the symbols you're going to work on is this symbol. It's called an integral symbol. Okay, it means the sum, and we'll talk about that in a later unit, what we're summing up. But the idea is when we do the integral of lowercase f, we're taking the antiderivative of it and we're getting the uppercase f. So basically we're talking about that f prime of x is the derivative of a function, and so I want to undo it. So I have dy is equal to f prime of x, and I bring the dx over, and I want to undo it by using this integral sign. Looks like an S, this integral sign, and we get y equals capital F of x, the undo, the antiderivative of the original function. This dx, don't worry about this dx. That's just the variable that we're using in this problem. Let's try some examples. So what we're really doing is working in reverse. And you guys know how to do this a little bit. Most of you were able to answer at least part of that bonus question. So you don't have to put any notation down here. It's just equals 5x plus c. Don't forget the plus c. So we're always putting in a plus c. The way we're going to do this, we'll talk about what the power rule is. It's like, what do I have to begin with to get what I want later? If I start off with 5x plus any number, that's why I just call it plus c, and I take its derivative, I would get 5 as a result. Just like for this one, I would have to have t to the fourth, and I need a number in front, so I need 1/4 t to the fourth plus any constant that will work. So this is the antiderivative. The next one, I need sine as a result, so I have to start off with negative cosine of theta, because that's my variable. Theta is my variable, plus any constant. This one is kind of what we worked before. I need x to the fifth, and that gives me my 5 later, minus 2x plus c, since I'm dealing with x, and I always have to put a plus c at the end. Always put that plus c at the end. This next one, I probably should rewrite things. And this will be x to the 1/2, and this is going to be x to the -2. And hopefully you're seeing a pattern here that when we do antiderivatives, if we have x to the n and we take the antiderivative, we're adding 1 to that exponent. But then I need some coefficient up front that gives me what I want. So really I'm just using the reciprocal of that. It's kind of what I did here, or especially in number 2. So for this one, to add 1 to a fraction, if I have a fraction and I want to add 1 to it, remember when I subtracted 1, it was top minus bottom plus 1? Well, it's going to be top plus bottom over bottom. So when I do this, I get x to the 1 plus 2 is 3/2, and I'm using this reciprocal, so I get 2/3, and I'm going to add 1 to this, so I get x to the -1, and the reciprocal of this fraction is -1 plus c. The best thing about the antiderivative, I can always check my results. So if I actually took the derivative of this, I would get 2/3 times 3/2, which is 1. X, subtract 1, 1/2, and -1 times -1 is plus 1. Subtract 1, I get x to the -2. See, I'm getting what I want. Don't overthink on this one. Antiderivative e to the x is e to the x, so this is 5e to the x plus c. Coefficients get a free ride. Let's move on to the next. Couple more. Let's see, I need negative cosine, so I have to start off with a -2 sine of r. My variable is r this time, plus c. And this is a special one. This one I do not rewrite. 1 over x has a special antiderivative, and you should know ln of x plus c, because the derivative of ln of x is 1 over x. Hopefully you recognize this thinking in reverse pattern that we're doing. So we will be taking antiderivatives. So the antiderivative of some lowercase f function is a capital F. And if I have a number up front, the coefficient just goes along for the ride. I have the same coefficient up front. So if you just have a constant, let's say, like we did on the very first problem, the antiderivative or the integral of 5x is just going to be k times x plus c. Don't forget the plus c. If it's a power function, instead of subtracting 1 from the exponent, we're adding a degree. Grab a different color. So for a power function, we're going to add 1 to the exponent. And if it's a fraction plus 1 is just numerator plus denominator over the same denominator. So the idea here, if I want to do this is going to be x to the n plus 1, but then I need something in front of it, and what I need to do is I need to use the reciprocal of the exponent. So this reciprocal is 1 over n plus 1. And don't forget your plus c. You always need the plus c. Now if we have an a along with it, goes along for a free ride. It's still x to the n plus 1. I'm still using that reciprocal, so n plus 1 on the bottom, but there's going to be an a on top, and there's a plus c. Now, if I have 2x to the 4th, well, this is going to be x to the 5th, The reciprocal of that is 1/5 times 2 gives me 2/5 plus c. Okay, let's move this up. The antiderivative of cosine is sine of x plus c, and an a up front becomes a sine of x plus c. Remember, we're working in reverse. And if I have sine, it's going to be negative cosine x plus c. And if there's an a up front, it would be negative a cosine of x plus c. Let's talk about what it looks like. Let's draw our little unit circle where we have that's my unit circle. And when I go clockwise, these are all the derivatives. Okay? So when I go in reverse, when I go counterclockwise, these are all the antiderivatives. So the antiderivative of sine is negative cosine, and the antiderivative of cosine is positive sine. Well, we get to the easy one, e to the x, easiest one ever. The antiderivative of e to the x is e to the x plus c. Don't forget your plus c. And if I have an a up front, it's a times e to the x plus c. That's a times. And we have the special one, 1 over x. The antiderivative of 1 over x, this is the one I would never rewrite as a power function. It's ln of x plus c, and if I have an a up front, it's going to be a times ln of x plus c. Okay, it's not too bad. We'll work on some examples, but I think most of you know how to do this because you showed me on the last test you can do it in reverse. The hard part is getting that coefficient up front, and we'll work on that in class. Okay, thank you, and ask questions.